So, welcome to lesson 15. Almost at the end of the teaching part of this course. It's gone by very quickly. We've got loads to go through. I'm going to go through as much as I can today and tomorrow. We got, I think, as far as this yesterday. We were just about to start talking about privacy on Solana. So I've got some topics about that. Starting off with a general pattern that's quite useful. So it's something you may come across. It's not specific to Solana, but it's something that is yeah, quite a handy thing to know about, which is the concept of nullifiers. And you see these in many different projects, and it's used when you want to show that something has happened or that something has been used, and it helps to prevent things like double spending. And an example of this is Zcash. It's also used in Tornado Cash. So they're those types of projects where you want to make sure that things aren't spent twice, but then you want to have some obscurity or some confidentiality as well. What you do is you need to be able to identify the resource that you're going to prevent being spent twice, and that's often done by taking a hash of that. When the resource is consumed or is spent, then you create what is called a nullifier from this hash, and this is stored in the application, and it's there as a signal that that resource has been spent. Um, but the way that the because of the hiding properties of a hash function, this gives us some confidentiality. So the hash that you get doesn't can't really give you details about what was actually spent. There's sort of more details that are needed. You can't really go back from the hash to get the details of, say, a token or something like that. So that's quite a useful pattern. Um, Generally, the area of zero knowledge proofs is widely used for to try to get zero knowledge and to prove that things have happened. We don't have time to go into that, but we've got lots of resources around CK. If you want to read up, we've got links there to that. The two aspects of that technology is that it allows privacy. It also allows proof of computation. You don't have to use both parts. So, for example, with roll-ups and on where we do layer twos, we do ZK roll-ups. They use the proof of computation part, but they don't use the privacy part. But if you want privacy, it does allow private computation. So how do we do this on a public blockchain? Um, and Solana is a public blockchain. All of the data is visible. So this is quite difficult to do, but people are making some attempts and trying to get things using things like ZK on Solana. We've also we talked about confidential tokens as well, and how you might try to do those. Other projects in this area, though, there's from the Light Protocol, they've got this idea of uh, the PSPs, the private Solana programs, and they use cryptographic techniques to allow private state alongside the public state. Uh, these types of things this potential can be very useful for things like DeFi. We saw the idea of confidential tokens. Also, things like games where you try to hide information about say, the location of players within a game, or if you're playing a card game, hiding the hands that the players have, etc. Um, so that's a little bit about Light Protocol. There's links there to that. Um, Also, the this gives the possibility of compressing on-chain state via these light layer smart contracts, and they use ZKPs to then prove the computation. Um, the point here, what a gross 16 circuit is. This is a type of zero knowledge proof. It's part of the way that a zero knowledge proof is created, and uh, you take a program and then you can translate it into this thing called a circuit, and then from that you can create a proof. Uh, a project that used to be around was Elusive, but that is now being sunsetted. They've moved to work more on a different type of technology. I think they've gone more for fully homomorphic encryption. Um, Other projects, this one Archeum as well. Excuse me. It uses a type of technology called multi-party computation, which is where people can jointly work on doing a computation, but each person will have some private input to that computation, and the other people involved won't know the details of that private input. Um, and that also involves homomorphic encryption as well. The homomorphic encryption is described in different ways, like so semi or fully, just because it allows calculation on encrypted data or allows operations on encrypted data, but not necessarily any operation. So depending on how many operations it will support, people describe it in different ways. Okay. Other ones, there's just some other ones listed here. You can check out as well. There's links to those, such as Dust as well. Um, I think. Yeah, I think it's an open question actually, how important privacy is to a lot of people. There are projects out there that are very much emphasizing privacy. Um, whether it is important enough to make the effort of building private aspects to chains and uh, potentially maybe getting poorer performance because you need to do some work for the privacy is an open question. I think people in Web3, particularly the developers in Web3, tend to be more concerned about privacy than the general public. So if you think about the adoption of these things, then I'm not 100% convinced that these things are going to be adopted, which I think is a great shame because I do like privacy. So. Okay, anyway, there's some examples and some projects for you to check out as well. One thing we haven't really spoken about, and I think it's perhaps not as large an area um, as, well, certainly not as large as DeFi, and maybe other chains have more of an emphasis on game development, but it's certainly possible on Solana as well. And it it has the advantage. I mean, all the scalability aspects of Solana are a great advantage if you want to uh, play games. So there's some guides here and examples. We've got this thing, the Turbo game engine that will help you build games. And it's targeted at a particular type of game, the sprite-based 2D games as well. One of the yeah, the difficulties that we face when we're writing games, or one of them is around game state. So there's an article there if you're interested about how we can synchronize that. The different ways that this is possible. So some of the different ways are shown here. So you could have the clients triggering an RPC call to get state, or if you've got WebSocket connection to stream data, that may be more performant, or you could have a server pushing uh, data from something that has happened on chain as well. So there are different ways to do that. Uh, you'd need to think carefully about that because the performance can suffer greatly if you get the wrong kind of pattern. Okay. Right. And I'm sorry, I do apologize. I'm having to go through things fairly quickly, but we've just got so many different areas to go through. So, a very complex area in blockchains generally is the one is MEV. This is really an emergent behavior that we get from blockchains that are doing computation and ones where there's something like a mempool or where transactions can will be in a pending state and then will get picked up and put into a block. And also the fact that the mempool is public, the transactions are public. Uh, It allows things such as front running, the idea that I could submit a transaction to do a certain swap, but then because that transaction is going through the network and then is going to get uh, is in a pending state, it can be seen before it is executed, and therefore somebody could see that and then try to get their transaction ahead of mine to take advantage of an opportunity or take advantage of the swap that I was going to do. Um, it's perhaps not as bad on Solana as it is on Ethereum because there's not the same sort of type of mempool. It's much easier to do this kind of thing on Ethereum than on Solana. And a point to bear in mind is that the transactions themselves, they are going to be ordered within the block, and that decision about the ordering comes from the leader, who is one of the validators. So in general, the validators have this power to decide about the order of transactions and whether a transaction will be included, and therefore that can be used for financial gain. They can expect higher fees to so that they will include transactions ahead of others, for example. Um, so this is quite a uh, well known phenomenon, but uh, it is a very complex one as well. There's a lot of research in the area and a lot of ideas going around about the benefit or the drawbacks of MEV and whether there are any benefits and what can be done about it. Um, it's not something that is going to be simply solved, I don't think. So, but people are working to try to mitigate some of the worst aspects. If we look at Solana in particular, there's a link there to an article that digs into this in more detail. But there are all sorts of behaviors that you get that will try to take advantage of information about transactions that are about to be processed. So one example around NFT minting, we have the fact that there may be something that's going to be an NFT that's going to be minted that will be much more in demand, much more valuable, um, and uh, that can then lead to people trying to get ahead of that and beat each other to these events, and um, there will be sort of sudden spikes in the number of transactions when this happens, and that those types of things with say NFTs being minted or tokens being released, they can cause big problems if they cause a massive spike in network traffic. It can affect the validator nodes, and that can cause problems as has happened in the past. Um, Liquidation is a process whereby people can see loans on uh, borrowing and lending protocols, see loans that are about to be under collateralized. And if that's the case, then the protocols themselves will make those loans available for liquidation. So people can go in, repay the loan, and they will receive the collateral, but they receive it at a reduced rate. So the liquidation, the people doing the liquidation will be able to make a profit for that. Um, but of course, those events, when that happens, people are going to be looking out for those. And again, you can get sort of the front running process because people will want to be the first to get these particular liquidations. Similarly, with arbitrage, where arbitrage is where people are taking advantage of price differences, say amongst decentralized exchanges, and you will get people racing to take advantage of those opportunities, and you may get front running involved there as well. Okay, so MEV generally then is this whole process, the idea of things being publicly visible and the fact that transactions will be ordered, and then that this can lead to certain types of behavior and people being able to extract value because of this. One of the reasons that we get less of this on Solana than Ethereum is down to the architecture of Solana. And for example, the fact that we have Gulfstream where transactions are sent directly to the leader when to be included in a block, and also we've got this point about shreds where the uh, when blocks are being produced, they can be streamed. So the the state that the validators receive is more continuous than, say, Ethereum, where they will receive one block and then they have to wait and then they receive another block. In Solana, because they're able to stream out parts of the block as it's being produced, then it's sort of more continuous. Um, Projects themselves obviously are very aware of MEV and may put in their own uh, protocols or own techniques to try to avoid it. We get, I don't know if I'm going to have time to go through um, this very much, but you can see here where there was a very large fee being paid um, to include a particular transaction. Um, and yeah, I mean, this is from a year ago, but you can see that $7 million in tips were being paid to try to get transactions included. Um, and so I guess the other side of this is when you're thinking about things like arbitrage and liquidations, is the fact that people may pump transactions into the network to try to take advantage of, say, an arbitrage opportunity. But if only one of those is going to succeed, then that means that many of them are going to fail. And so we do end up seeing lots of failed transactions that are failed arbitrage transactions on Solana. So it has a negative effect because it clogs up the network because of those. So other ways to cope with this is to sort of have extra mechanisms by which transactions can be bundled together and then is built into a block. And so this may be a private space where so that people can't get details of the transaction. So you could submit a transaction to these out protocol block spaces, and then that could get forwarded to the leader. So it adds some privacy around the transactions. If you do that, then you get other roles involved. So you have searchers who are there who are um, putting together the transactions in bundles and then submitting those. Yeah, I won't go into. I don't really have time to go into all of this, but yeah, this is showing you the different roles, the searches. Um, the reason that projects like Gito would be wanting to do this is be, because things like decentralized exchanges are particularly targeted for MEV opportunities. So it could give it can give a very negative user experience. If you want to do a swap, for example, and you think you're going to get a certain price, but then somebody comes in and front runs you, then that's a negative experience. And so it makes sense that exchanges would want to find alternatives and a way to make their product seem safer and not able to be front run. Um, the as I said, the we have problems with network congestion because of this. Um, Also, there is a problem. I think this is general to blockchains, to other chains as well, that um, because there is economic benefit for validators by uh, getting fees for ordering transactions and receiving this value from the blockchain. Um, with economies of scale, this can then encourage centralization. So people who are able to take advantage of MEV and make money from MEV will then be able to spend that on providing stake to run other validator nodes. So yeah, it can encourage centralization. We can certainly provide you with many more resources to help you out if you're thinking, if you want to know about auditing or you're thinking of becoming an auditor. Uh, the the way I like to look at it, auditing in general, is that you have to be aware of different levels of vulnerabilities, and there are vulnerabilities that exist at the sort of the Web 2 level and the sort of operational security level, and then there are ones that will exist in sort of apply to all blockchains, and then there will be some that are very specific to a particular blockchain, and so you do need to be aware of vulnerabilities on Solana, and we've spoken about some of these, particularly around the way that accounts work and how we need to be sure to validate those. I think it's probably an advantage actually that programs are stateless in that sense. So it does allow us just to really concentrate kind of on how our accounts are being used. But yeah, you do have to look at things a little bit differently to say EVM. Now, the the process of an audit, if you haven't seen this, uh, it should happen when the code is ready to go into production. So it's important that it is really the final step of the development life cycle where you need a a code freeze when the code is being audited. You can't audit any kind of moving target. So the code has to be finalized. Uh, the when audits are being done, they will be for a specific time. The auditors only have a certain amount of time, it's maybe 2 weeks or something, whatever it is, in which to investigate the project. So from the point of view of the developers who have developed the project, it makes sense to try to maximize the efficiency that of the auditors by providing, for example, very clear documentation. The auditors need to come up to speed on the project as quickly as possible and to understand it as quickly as possible. So therefore, anything that the developers can do to assist that will mean that the auditors have more time then to look for vulnerabilities. So yeah, provide good documentation if you're being audited. For example, things like diagrams of accounts, how they relate to each other is very useful. What is always good is to specify the roles within the system. There's usually going to be some type of administration role. There'll probably be a normal user role. There may be roles around deployment. All these roles need to be clearly documented, and then you should point out, which addresses are being used for these roles and what permissions they have, etc. The code itself, it does need to be clean in the sense that you need to take out any sort of spurious comments. And if you leave a comment in the code like a to do, or, you know, question mark, does this work? Then the auditors will pick up on that and will raise this as an issue and say, there is something missing here, or, potentially this doesn't work properly. So make sure you take all of those things out before the audit if they're no longer needed. Um, Also get rid of any unnecessary code or code that is commented out. It just adds clutter and it just wastes time trying to read through that. As part of the audit, it will be expected that there is a good set of unit tests, and it will be assumed that that is comprehensive. The auditors are not there to do the testing for you, so it is expected that you will have done that. That will be comprehensive already. Uh, the auditors may do tests for themselves to investigate certain conditions, but that they do expect you to have, covered all the bases first of all. It's very important that you make sure that those tests will work and that the auditors can run those tests very easily. It's when you're auditing, it's one way to investigate the project initially is to run the tests. So for the developers, make sure the auditors can easily run the tests and they're not missing dependencies or anything like that. Um, in terms of the how the audit is conducted, um, there will be a multifaceted approach. So there will be some manual review. There will be tools used also. My experience, and yeah, I think it's still the case, is that although the tools are useful, and we certainly use tools to do automatic checking of code, these are not uh, completely reliable, and we do not completely rely upon them. So still our main focus is on manually inspecting the code. Of course, yeah, use the tools. I mean, if you've got them available, then it makes sense to use them, but don't just use the tools and think that's the end of it. You'll find out much more by using your own experience and working through the code manually. Um, at some point you are going to go through the code line by line. How you do it may vary. Um, I think it's useful to go through the major um, flows within the program to work out the different types of transactions and how they go through the program, rather than just necessarily starting in the first file and going through that line by line. But it depends. It depends how you like to do things. Um, this is just an example. Again, some of the common problems. I just included an example here of what that would look like. But this is the type of thing that you're going to be looking for as an auditor. And I don't know if I've got the other. So you'll need to go through the code and be aware of the common vulnerabilities. So look for them and see if they are happening. But still, you'll have to go beyond those. So the very common vulnerabilities, of course, you should check for those. But there will be other things you need to check for, and a lot of the vulnerabilities that we see are more economic in nature. So you need to think about issues such as, could a price be manipulated, or is the precision of this price too small, and is that going to create problems further down the line? Things like that. And understanding the business logic behind the program is essential then. You really need to understand that and think about the way that users will normally interact with the code, but then also think, well, you have to adopt a hacker mindset at some point and think about, you want to break the code. How could you possibly do that? And do things that maybe the developer wouldn't have thought of. So look at areas that are of the project that are maybe quite complex or that haven't been sufficiently tested, and maybe focus on those. Uh, and try to do things that don't follow the normal flow. Try to think of things that don't follow the normal patterns that the user is expected to follow, because those will have been tested. But for example, if you're expected to do transactions in a certain order, um, do those transactions out of order or repeat the same transaction twice. All those types of things that the user wouldn't normally do, you should be thinking about when you're looking for vulnerabilities. Okay. Um, some examples of tools. There's not as much on the Solana side as other chains, but there are some tools as well. Static analysis tools can be useful. They need to know patterns of vulnerabilities though, so they won't detect anything that is very new. So you do need to be aware of that, but they're worth trying. Fuzz testing is a useful technique because this throws random values into the tests, and so it's trying to find values that maybe the developers wouldn't have thought of when they're doing the testing. And you can send in a lot of values because you can automate this, so you can send in many values and run this many times looking for edge cases. So that can be quite useful. There's an example here of Trident, which allows you to do that. I've got links there to their documents. There's also a boot camp. There's some videos there that they ran. Yeah, it gives you an idea of that. And then when you're going through the code, maybe you find a vulnerability, then you're going to have to create an audit report around this. This is the deliverable, and the report itself will have a summary of the findings, and quite often that is done in two ways. There will be a technical summary that is there for developers so they can easily understand the technical aspects of the issue. And then there may be an executive summary, which is more for the business side of the project so they can understand the potential impact of any issue. And that perhaps would have less technical details because it's being targeted at a less technical audience. You do need to specify exactly the scope of the audit, which files were audited, and I mean, presumably you're going to be working from a repo, so you'll need to say which commit you're working from, so it's very clear what code you are looking at. Then you need to specify all of the vulnerabilities you found, each issue. You need to give it a rating as well, a risk rating. The labels for these do vary. There's some examples here. You tend to get things similar to this. Of those, the informational uh, issues will be things that perhaps are not a security problem, but you may show because it illustrates a better way of writing some particular code, or maybe it's showing an optimization that could be done, that kind of thing. You will need to, it's a good idea if you're writing a report to have to describe what each of these ratings means. And with all of the issues that you put into the report, you will have to defend what you have written as well. The developers may come back and want to know more, or may challenge you about why you think something is a problem. So you will need to put in sufficient detail that it's clear to the developers why there is a problem. It also can be useful if you can provide a test to show the developers how to recreate the problem. And then it's important when you're writing the report that you do it in a very factual way. You shouldn't use any kind of judgmental language and don't say, oh, this code is badly written, or it's obvious that the developers aren't experienced. Things like that are very much counterproductive. So you need to just be very positive, very factual about anything that you find, because you're relying upon the developers to understand what you've said and to act upon it. Uh, and one point about that, when you're doing the process, you will issue an initial report showing the findings, and then the developers will take that, and it's up to them what they do about it. They don't have to take notice of what you've said at all if they don't want to. I mean, you're there to advise them, and you need to do that your best to give them as much information about any problems as you can. But it's the responsibility is with them as to what they do about that. And so if they want to ignore the findings that you have shown them, that's their responsibility. That's their right to do that. Um, and what happens is that after the initial report, you will give the developers time to fix any problems, and then you will issue a final report which goes through the fixes that they have done and then gives a summary of the state of the program after the fixes have been applied as well. Um, okay, so that's yeah, very quick overview. In fact, mostly on other chains. So let me know. The this here is just to pick up on a particular bit of terminology that you may have come across. Commitment levels. This is to do with the the way transactions are processed. I have touched upon this a little bit. Um, why I was talking about transactions and the fact that to know we want to give them a lifetime, so that we can get rid of them if they have been around too long within the network. In order to do that, then we need to have a starting point, and that's what this is all about. The first part here is talking generally about how the transactions are submitted and processed. It does make the point that it's the protocols used do change. And so, for example, between the client and the RPC node, we are using HTTP, which means that if information is lost, then there will be asked for again. But with the after the RPC node, it's UDP. So if things are lost, then they will stay lost there. There's no sort of feedback on that. Um, so yeah, we're interested in the lifetime of the transaction, and um, you can choose this thing called the commitment level when you are sending, when you're creating your transaction, and you're giving it a kind of a starting point by saying the latest block hash. So what you judge as the latest block hash, which is then going to be used as the starting point for your transaction, in effect, or to indicate its age. Um, it can be, you can choose different commitment levels for that. So if you choose finalized, this is a block that is seen as completely irreversible, and it has been completely accepted. There's absolutely no question about this block. That could mean that that is a little older. It may not be the very latest block, but that you can use that as the starting point if you want, although that is a little earlier. Um, the next type is the confirmed. So this would be where a transaction is included in a block, but that hasn't been, we haven't come to consensus about that yet. It hasn't been confirmed on the network. It probably will be okay, but it is not as finalized as the finalized block. Um, the we also have the processed level as well. Um, but that is the least finalized of them all, the least secure. So the recommendation from Solana is you use the confirmed commitment when you're sort of providing a starting point and saying, I want my transaction to be judged against this particular starting time. It gives you more time effectively than a finalized one, because it's a little later. So your transaction will look younger, I guess, than if it was based on the finalized commitment level. Um, so which means that it will then be around for longer. So there's less chance of maybe your transaction being thrown out because it's too old. And presumably you wouldn't want that. So yeah, that's the commitment level. This is a very general bit of advice actually that I wanted to share with you, and it's a talk I saw, and there's a video there to it. So it's talking about sort of really stepping back here and just talking about building projects generally in Web3. And I think it's worthwhile thinking about some of these points, especially, well, for your final project, maybe you're not going to take that as seriously. But if you're thinking about a startup, if you're thinking about creating a product, I think there's some useful tips from that. The first one here, the idea of the build fast and break things approach, uh, hasn't worked in Web3 very well it's because of security problems. It's the break things has tended to break the projects that have tried to do that. So it's not an approach that is recommended generally. Of course, yeah, there's the opposite as well. You don't want to delay things too long. Um, the one point here, actually, these second 2 points, I think, really the same type of thing, is the idea that you would release something so that it's being used in a real world, in the real world, and in the context that you're expecting your product to be used. Um, but it's probably to do that, it's probably better to release a product that only has a very limited amount of functionality, because you're going to learn much more about your product from from what the users are doing with it when it's actually being used than you are by thinking about it and designing it before release. So it does make sense to be fast in that sense and release something a little bit early. Um, but to do that, you need to restrict the amount of functionality that is involved in the product, and hold it back for version 2. And it will your next version will be a much better version because of all of the experience you've gained uh, uh, from version 1 when you've had users really using it. And yeah, here they say go for 50% of the thing that you're trying to build. Um, and yeah, maybe think of the V2 release as being the real launch of the product. Okay. So yeah, just some ideas there for you when you're thinking about building something. Um, I hope that yeah, I hope that those ideas will be useful. Okay, we've spoken about wallet adapters. We looked at how you can connect, you can build UI, how you can connect to a wallet. So a very fundamental part of the UI is interacting with the wallet. And so there are wallet adapter libraries available for you. So I've got some details here, and demos also. Um, yeah, this is this particular one. Yeah, the wallet adapter library is a package that you can include there. Some details about this, and if you want to use it, there's a guide to it there as well. And you can use it, and then you have different options of the front end frameworks that it will interact with. So yeah, take a look at that. And then on the same theme, just one thing to be aware of. If you're doing this using Anchor, you need to do things slightly differently. This article is very good, so do have a read of that. This shows um, the uh, yeah, this is the Anchor side here. So this is here you have to use Anchor Wallet. There's slightly different way that is done. Whereas with native Rust, you would be using you wouldn't need to do it. You would just use you would just uh, have the method use wallet rather than use Anchor Wallet. Okay. Um, So just be aware of that. Okay. Airdrops. Quite a common thing to want to do. I've also already spoken about a tool that will help you with these, which is Gumdrop. And uh, you can use that. Or if you're building your own, then sorry, Gumdrop is particularly for NFTs, I should say. Airdrops generally, the you could write some code that would go through a number of addresses and send them some tokens to do the airdrop, but that is probably going to be inefficient and be expensive, particularly if you have a lot of addresses. If you only have half a dozen addresses, then that's not problematic. But if you've got lots of addresses to go through, then doing something like that is going to be very expensive for you. So a pattern that is very often used is the idea of users claiming a token that they're entitled to. So they will have submitted their address uh, to be eligible for the airdrop. You can then tell them they are eligible and that they need to call a particular function. So then they're initiating the transaction, and the transaction just does their airdrop. So if there's any problem, it would only affect them. Um, but there are different, yeah, have a look through the article about different approaches. Um, if you can store these things off chain, it does make sense as well. Um, and be aware of the fact that we have to use associated token accounts, because the user will probably not have an account, a token account for that particular token already. These are probably going to be new, uh, specially minted tokens, and so the accounts won't exist yet. So you need to bear that in mind. There's a tutorial there for you also to take a look at. Uh, as I said, yeah, Gumdrop is available for airdropping NFTs as well, and that will integrate with Candy Machine. So yeah, you can use that. Okay. SocialFi. Okay. Yeah, a lot of these topics, they tend to be very much uh, of the moment. And I don't know. I mean, this became very popular maybe a year ago, I guess, something like that. I don't know how popular it still is, but there's some example projects for you there. The Friend Tech came about, and that people have done similar things to that. So there's an article about that there. It's all around um, tokenizing, sort of social networks, that kind of thing. Okay, but yeah, have a look at that. Now, a new technology that also became popular quite recently is our blinks and actions. Um, these are this is technology that's been used by multiple chains, and but it has tied in very nicely with some existing projects on Solana. The idea behind them, we have actions that are an API that will give you a signable transaction for something, and then the blinks are links that clients can use to get those to interact with the particular action. Now, the this can be initiated by uh, buttons or QR codes or URLs that can start the action. If this sounds familiar, then I'm pleased, because this really is what the way that Solana Pay is working. And in fact, they've kind of integrated that there, so they are now called actions. It's when I described it with about Solana Pay, the idea I was using was the fact that it would be a commercial transaction, but it doesn't have to just be payments. You could use it for many different types of things. And it's the reason that this is important, because this idea is quite simple, I suppose. It's very similar to just common client interactions, but the point is that it's being done in a way that is very easy for the user. It's really making it as simple as possible for the user to get involved and to initiate these actions. There's some details here from the docs about the some of the things you could do with action, some use cases, such as helping with staking. We've seen the example of a retail store using a QR code. That's really what Solana Pay was illustrating. We also could use it for minting and then use that token to gate something. You could use it to accept payments on e-commerce sites as well. This idea of a trading account, if there's going to be a margin call, which with a trading account it would mean you'd have to have a certain amount of funds available for that, then having something very simple to allow you to top it up makes a lot of sense. Um, Using it to allow things to be bought within games makes a lot of sense as well. Really, is just uh, making these things as simple as possible for the users to get involved with. So lots of different ideas there, and they are supported by uh, most of the wallets now. We've spoken about this already. I don't know if I need to go through. Well, I've got the examples. So when we looked at it before, we were looking particularly at Solana Pay, but this is the more general idea. So I've got some example code here. So uh, you would use a get request to get the metadata for the particular action, and there's some various examples here of different ways to do that. This is for donation. Sorry. Okay. Um, and then when you've got that, then you can do a post request to execute it, and that will include the wallet that is going to be used for this, and we'll set up the transaction and execute that. The blinks are just a way of making these available in a very nice, very easy way. If if you do this, there is this dialect are very much involved in that they have a registry, the dial 2, where you can see different types of blinks that have been set up. There is some security around this as well. So you you would opt in with your wallet to use those, and it will be checked if you visit something that is offering the um, actions and blinks. Yeah, the registry there, so you can have a look at that. Let's take a quick look. Oh, this is this is for a number of different chains as well. But yeah, you've got some examples of what it would look like. Here you've got some examples on Solana of what you can do. So it's really a way of having a very simple little interface that people can interact with, and easily set up a transaction. There, yeah, okay. Yeah, I'll leave it there. I think that hopefully makes sense. Okay, so another topic that was asked for was Mollusk, and I've put this in the notes here, though I may move this around a little bit, and because we've got other notes about testing and some of the testing framework, so I may move this later, but I can go through this now as well. Uh, so obviously testing is very important, and you can take different approaches to that. And when you're one big difference between sort of traditional, sort of pre-Web3 technology testing and then Web3 testing is that we are interacting, via a blockchain. We've got this extra complexity that is going on, that the actual interactions are transactions that are being sent to a node and being picked up, put into a block, and then executed, etc. Um, so how you test the programs that you've written or the scope of those tests is debatable. It's really up to you how you want to think about that and how much of the entire process you think is important. And as you can do the testing at different levels, and certainly as you are developing your program, you would be thinking about doing this at different levels as well. Um, so you could, you've got the idea that you would be looking at the program code pretty much by itself in more in isolation and looking for the correctness of that. And when you're happy with that, then maybe you'll be looking at how that works in a local environment, and you would be putting it in a local environment before then putting it on a test network to see how it works there. So this is uh, Mollusk is all about sort of fitting into one of these sort of approaches to testing, and um, the the traditional ones, I suppose, were the fact that you would set up maybe a local validator, but there's a lot of extra things happening when you've got that maybe you're not so interested in straight away, and it may be better to have something more lightweight and more something that you can use to really target your program and think less about what the validator is doing generally. Um, I think, yeah, this is more designed for more experienced developers as well, because it's particularly thinking about performance as well. Um, so yeah, the idea behind it, they're aiming to make it very fast, but they're making it quite minimal in order to do that. So it's not a full validator, and it's ignoring certain things deliberately. The It interacts directly with the SVM, so it's sort of missing out everything that happens from your transaction, I guess, hitting the RPC node to when it's actually being executed. It's just ignoring all of that, um, and really ignoring the the state involved as well, and just trying to keep things as lightweight as possible. Uh, so that if you do that, then you'll get better performance from your testing, which can be very valuable. Um, but it means that you don't have the context that you would normally have when your program is running. So you do have to be aware that it the testing that you're doing is quite limited in its scope. It's much more restricted than the usual testing that you are doing. And it also means that you have to, if you want to include context and you want to include state within the testing, you have to be very explicit about that and set that up specifically for the test. Okay. Let me just um, it does follow the some of the ideas that you're seeing before, the idea of using mocks and stubs when you're developing, which can be a very efficient way of doing things like test-driven development, for example. There's some details here if you're interested in how to use it. Um, this I think is adding it to expecting you to use Anchor as well, but it shows you the steps that you need to go through, so you can list it as a dependency. Um, um, and you can then, when you're creating a project, you can specify that you want it to use Mollusk, or you want a special template set up to use Mollusk there. Um, this is some details of the what you will need to do to the config when you're running tests. So you have to be aware of at that. This is how you actually instantiate it, and you need to tell it the program ID of the program that you've got. So there's an example there. Yeah. And then there's an example here, just an extremely simple one, to show how you can use it to process a single instruction and then check the results from that. So yeah, so you're setting up the program here, setting up the instructions. You have to work out the accounts yourself for this. You've got the program, so you can set up Mollusk with the program ID, and then you can ask it to execute the instruction. Once it's done that and returns results, then you can check that result. And then you may also want to look at the state of the accounts that you've provided afterwards as well, to see what has happened there. Remember, I mean, this is a general point about the programs, that the programs will return an OK or an error. And so if you want to see the state changes, then you have to query the accounts. So there are ways that you can set up the environment as well. Some details here. You've got an API available also. I don't know much about most of these. I've just been taking these from the notes, but hopefully they'll be useful if you want to try it out. Oh, I'm sorry, formatting has broken here. I do apologize for that. That should have been in a code block there. But yeah, you got more details there, and then what the results of that coming out there. You can do benchmarking as well, and it will give you results into the directory you want that you've set up in the config, and tell you about the compute units that you have used when you ran the tests. You can also set up some fuzz testing as well. There's some details of how you can do that and integrate that into Mollusk. Yeah, so that's a little bit about it. I think where it fits in, I would say it's something that you would do when you are more experienced and you are maybe looking to do things like benchmarking, or you're looking at very specific aspects of your program and you want to focus on it in a lot of detail. You starting out, you would probably just use the standard testing that we've covered before, but perhaps later, particularly if you're looking at optimizations, you want to test those, then you may want to use the Mollusk framework. Okay. All right, let me just check. Slido. Okay, that's all right. Okay. Oh, and this, yeah, sorry, this, yeah, here you go. Here's the more details about that. I thought I'd got this in. So comparing it to some of the other frameworks you might want to use, and the use cases. So yeah, check that out as well. Okay. Right. Moving on. Optimization. Well, we've just mentioned, how you can be testing for optimization. And whenever I talk about optimization, I always include this quote from a giant of computer science. And I genuinely believe this, that because I've seen this so many times, that people very often do optimize at the wrong time. And they will optimize some code and spend a long time doing that, only to find that maybe the specifications have changed and all that code gets thrown away, etc. So really, you should be when you're developing your product, you should be making sure that it works correctly first of all, and then finally looking at optimizing it. That doesn't mean to say you can't be thinking about the best ways to design your code and approaches that would be better. But sort of going into the kind of the tweaking that a lot of developers really enjoy doing, that's the kind of thing that has to be done last. Okay. And when you're doing it, you need to be very aware of the circumstances in which you're optimizing for, because the the transactions that are going to go into your product could vary in what they're trying to do, and it may be that by optimizing for a particular path through your code, that would make a different path go more slowly. So you need to be aware of those kind of trade-offs. Um, and you need to test. That's absolutely critical. Again, many times I've seen people making assumptions about, altering a certain thing will produce an improvement. And it is often quite counterintuitive as to what does improve the performance of code. So always test the performance, then make a change, and then test the performance again to see if that change had the desired effect. Okay. Um, some things you can do that may be useful, just general things, like removing logging. So an example here that will reduce the compute units for doing that. Other things, uh, saving the bump value. So we saw that when we are deriving a PDA, that we will need a bump value, but we may be deriving this many times. We may be deriving it in different places in the client or in the program, and so it makes sense to save the bump value that you get for that particular address so that you can reuse it. And yeah, there's some example code of to do that there. Um, be aware of the data types that you're using, so use those appropriately. Larger ones may be more expensive, but don't use data types that are too small. Make sure you're never going to get any type of overflow or truncation or anything like that. So the emphasis should be on accuracy and security. Uh, Obviously, if you've got a very large data type that is just holding 1 bit, then maybe you could make that smaller. But yeah, just be very aware of the limits that you're going to hit in your code. This is, yeah, a little bit more advanced, I guess, a bit about serialization. There's a link there to a blog to talk about it. It's something I think we came across this yesterday as well, the idea of the zero copy. The fact that um, yeah, you can use it to make the process much cheaper. Um, and it may help you um, avoid hitting limits. I said that in addition to the compute unit limit, we also have a limit on the amount of memory that we can use and the size of the stack. And if you're hitting those, then yeah, you may want to do the zero copy. And there's a macro within Anchor that allows you to do that. Um, so there's an example in a repo, example of zero copy there for you to have a look at, and there's more examples in this repo. Let me just check that. Yeah. Uh, so have a look at that if you're thinking about some optimization. Okay. How are we doing for time? I think this is the last bit, so I think I've managed to get through most of it. But it is this next bit, there's quite a lot, so I'll perhaps skip through some of it don't want to spend too long on it. Um, so it's about we've kind of we covered a little bit, I think, earlier. We spoke a little bit about bonding curves, but someone asked particularly about this, so I wanted to give you some notes. So I've got quite a lot of information here that I think you're going to find useful. So this is around the idea of doing things like a token launch, and these have the way these have worked has evolved over time. But you tend to get things like uh, the initial coin offerings, where they had their problems, the way they were done. They developed um, into things that had some kind of oversight, um, and but for a decentralized approach, we got the IDO becoming a standard. But the problems with these you tend to find are things like them being vulnerable to bot activity, and the fact that working out the price can be difficult. So other things that have been tried then, these liquidity bootstrapping pools, um, which are reliant on bonding curves. And so using these is trying to solve some of the problems that we get when we're trying to do something like a launch, and make it transparent, but also to try to prevent some of the problems that other techniques have had, such as the problems with bots, or the uh, problems with prices changing in a way that we don't want. Okay. Um, I've already mentioned Pub Fun, because they do something similar to this. I mean, they've standardized a lot of things, and they have a particular bonding curve that will allow a token to be released in a certain way and a price to be derived in a certain way. Um, and yeah, we've got other projects as well. It's the fact that we've tried to automate these and tried to use things like bonding curves to give price discovery has meant that we don't then need as much outside regulation as well. So it has become more democratic, the whole process. Um, of course, it is very competitive as well, so you have to be aware of that. Yeah. So just going through some of these things. So I mentioned the idea, um, the IDO, where a something will be launched through an exchange, a decentralized exchange. Uh, this could be then done at a fixed price, and then that can be used to um, sorry, for sale of the tokens, and then that can be used to create a liquidity pool. And so as soon as that's available, then you can trade on those. And there are platforms that will help with that. The Another approach, though, has been this idea of the LBPs, um, where the instead of the token price being set as a constant for the sale, it is designed to change in a certain way. So here we've got the idea that it would start at a certain level and then decrease over a set period of time. The way that this can be achieved is you pair it with an asset such as a stable coin, and then there would be the weighting of this would change over time. So it may start as 90% of the token, 10% of the stable coin, and then move to a lower weighting. Um, so 20% of the token and 80% of the stable coin over time. What that is designed to do is to um, that mechanism by itself is designed to move the price down, or to give a downward pressure to the price. What uh, and that is done because it's expected to be counteracted by the buy pressure coming in from the participants. So instead of the price just increasing as there's more pressure to buy the tokens, we've got sort of two factors coming into play, and hopefully together um, they will yeah, sort of keep the price more constant. Also, this can stop or can make front running less of an advantage. So because there is less incentive to buy early in this process. So, in previous approaches, we may think that we should buy early because the price is going to go up. But in this case, where that's not necessarily the case. There is this pressure to move the price down as well. So that should take the incentive away from people to buy early. Um, Other ways to do it, so you can base this on a bonding curve featuring a rising price, and I I think we looked at bonding curves, didn't we? And we said that they rely upon the idea of the price being dependent upon the current supply. Um, Let me see. I don't have much time, so I want to go through most of this. But this gives you some comparison of the different types of mechanisms involved um, for these different approaches. Okay. Um, so um, yeah, for example, the IDO is very susceptible to front running because there's the advantage for people to get in early. Um, but with the LBP, then there's less advantage. So there's resistance to bots, etc. Okay. And here you've got the use cases that may uh, benefit from that. I have already spoken about bonding curves. I've just included this as background. I'm not going to go through it because it gets quite complicated. All right. Thanks, everyone. I hope you all have a good evening, and I'll see you all tomorrow. Thank you.